guys, this is the paper that we need today. It looks a little weird because this is the first one that you've done that I have made myself. And made this a couple of years ago, and I admit that it's not very professional looking, but it works great for what we need to do. Notice the first thing is that I trimmed the edge all the way up close to those letters, and I'm going to do that on both sides, right up close. Then, when I go to fold it, I know the first fold is going to be right on the edge of these graphs, but as straight as I can make it. And then here, I'm right by this word miles. And when I do that, they should come together. And there's a little bit of a gap where I didn't cut it directly straight, but it's close enough that I can see. Then when I'm done, I'll just put a dot of glue at his hands and feet for the little guy and glue it onto page 26 in my notebook. I'm also going to use a little bit of color. You can use a colored pencil or a highlighter, but I just want to separate quickly my directly proportional, which, you know, your math teachers usually just call it proportional, my inversely proportional, okay, which is kind of like the reverse or the opposite of being proportional, and the non-proportional examples that I'm going to go through with you. So let's talk about, first of all, our directly proportional. We need to be able to tell whether the information we are given is a proportional relationship, whether it's given to me in an equation, whether it's given to me on a graph, or it's given to me on a chart. So if it's given to me in an equation, my directly proportional relationship will be in the form of y equals kx, where k is the number being multiplied. It will, on a graph, have a straight or a linear line going right through the origin. So that is so important. Let's jot that information down. 2 points here to remember. My line is linear. That means it is straight, and it goes through the origin. And if you don't know what the origin is by now, let me just tell you. It's at point 0, 0 there in the corner. Okay? And finally, we can find in a chart, if we divide y over x and we get the same number over and over again, we know that's proportional by finding the k is y over x. So if you've got a chart and you're supposed to see if it's a proportional relationship or not, then you're simply going to say, 30 divided by 1 is 30. 60 divided by 2 is 30. 90 divided by 3 is 30. And 120 divided by 4 is 30. All of those numbers were the same. It is a proportional relationship because it's being divided. Again, k equals y over x. So that's pretty easy when we're looking for a proportional relationship. Y equals kx in an equation, straight line through the origin when it's on a graph, and take the y, divide it by the x each time, and if you get the same value, you are looking at a proportional relationship. All right, so that was pretty easy. That's information you probably already knew. So let's quickly touch base on the other two. The next one, if you'll remember, is inversely proportional. And in our class, we've been doing some lineups. The key to remember here is that x is on the bottom. That's kind of a boo. If our x is at the bottom, we know it's inversely. We don't want that. We also might notice that on a graph, the line curves. So that's going to be an inverse relationship. Let's label that. Inverse is kind of the reverse or the opposite of a straight line, isn't it? It's the curved line. And finally, another key thing to tell, and this would be the easiest one, is if they give you a chart, you probably already checked it to see if you can divide, and it gives you a proportional relationship. If it's not, why don't you check and see if you multiply those numbers, if you would get a same. So 1 times 16 is 16, 2 times 8 is 16, 4 times 4 is 16, 8 times 2 is 16, 16 times 1 is 16. Yeah, see, when you multiply x and y, you got the same ratio. So those are our examples of inverse. X is at the bottom. Let's write a note there. That's your key to being able to tell. If x is at the bottom, it's going to be inverse. If it's a curve, it's inverse. And k equals the multiplication of x and y. Finally, the last one that we're going to talk about is our non-proportional. And so that is kind of vague. There's a lot to that. But the key to remember with that one is if you have a plus or a minus. That's kind of another boo. If you have a plus a number or minus a number, can't have any pluses or minuses in our equation. The reason you can't is because that raises our line crossing the y-axis, not on the origin. It's missing it. If it's a plus number, it's above the origin. If it's a negative number, it's below the origin. So that would make it non-proportional. Okay? Non-proportional. And with the chart, you will just see that there's not a pattern of multiplying or dividing. So you're out of luck there. You can see I don't even have a way for you to find the constant, except it's normally going to be still the number in front of x. But in the chart, it's more involved in finding it. And there you go, guys. A quick review on how to tell from equations, graphs, or tables if your relationship is proportional, inverse, and non-proportional. And guys, this paper alone will help you make an A on your test. One more thing to remind you. Other words for this K that we always talk about, constant. Another one, the constant of proportionality. Another one, and this is what you'll call it next year, slope. And instead of a K, they'll probably have an M, but it's the same exact thing. We call it, Lot, the unit rate or the rate. Okay, thanks guys, and shout out to my amazing third hour. They are in class while I shot this video and stayed silent.